So in this video, what we're going to look at is the different types of variables that we have and why we would want to use one type or another one, and what's the basic syntax and some motivation behind variables. So what do variables have? They all have a few things. Here, I'll switch to typing so you can read more easily. Variable is really attaching a name to some kind of value. So they always have a name. And what else does a variable always have is in C, variables always have a type, and they also have a value. And there's actually also a few other things that variables have in C, which we won't talk about too much right now. They also always have a scope and a size in memory. Okay, so those are all the things that a variable has. So for example, if I have a variable declaration like int my age equals 35, then this has a type, which is int, a name, which is my age. The name can be anything you want, pretty much. We'll talk about some restrictions on that. And the initial value, at least, is 35. Okay, so those are the three things that every variable is generally going to have. But there's a difference between these three. So the name and the type, and actually these things down here as well, are all known at what's called compile time. So these things are basically not changing, that they're known at the time that you compile your program. So they don't depend on how the program is run, who types something in, or anything else. But the value can depend on what somebody types in. And so that's what's generally going to be different every time you run your program. And that's really important, and actually is important for how we think about how errors can happen as well. So what can variables do for us? I was thinking about this a little bit, and I thought of some examples. So I don't know how familiar all of you are with submarines, but I was surprised to learn that on a submarine, they don't use the names of some of the roles. So for example, there's like the eng is the, I guess, the engineering officer, the division head on a submarine. And I was surprised to hear from a friend of mine who's a sub officer that this, you, even outside of the context of working, you still might refer to this person as eng. Or I guess there's also like weps and nav and some other things like that. So this is an interesting case, I think, of where there's this name where it's not attached to a specific person, it's more like attached to that role. So every submarine has an eng, but that's going to be actually a different person, but we could use the same name for all of those. Another example, maybe closer to home, is I know a magical email address in case I need something to happen, is I can look up what company one of you is in and send an email to this kind of address. I don't know why I picked 17th company. Those company officers rotate in and out. I've known some company officers, but I don't have that much interaction with them. But the nice thing about this name is that no matter who's currently that company officer, I know that I can send them a message by sending a message to this email address, and that's pretty convenient. So these both things are both kind of like variables where they have a name and they have some types or some properties, like I know always that the company CO17 OFCR is going to be the 17th company officer, but they're not a specific value until we use them, and they could be changing over time. But there's also some pitfalls, and thinking about this company officer one, I might write a company officer email that says like, hey, Lieutenant, I need something, 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 whatever I need from this company officer. And maybe that'll work for a while because I'm thinking in my head, yeah, the company officers are usually lieutenants, but of course they're not always lieutenants. Sometimes they might be Marine captains, or I don't know, maybe LTJGs are sometimes company officers. I don't think so, but in other words, I'm making some assumption here based on how I'm used to using this name, this variable, but it's not always going to be true. And you can think of times when you might, I think we can get mixed up with this when we use like gender pronouns, when we might address someone and we don't actually know what their gender is. We make some kind of assumption based on past experience or something, and that can be bad. So this is an example of thinking, coming back to programs, it's an example of an error where me writing LT here might work for a while and might have worked in the past, but it's not always going to work because if we're thinking about as a programmer, I need to think about all the possible values that could have taken and account for that to avoid errors in my program. Okay, let's look at some specific types of variables now. And there's 3 general categories. So the first category that I want to talk about is numbers, numeric variables. And there are a few different kinds of numbers that numeric types that happen in C, but there's really 2 that we're going to focus on, which are int and double. So what are some examples of these before we get into the details? So an int can be any whole number like 0 or 5 or -3. So ints can be negative, or 267. So those are all ints. And doubles can be those kind of values as well. They can be positive or negative, but they can also have fractional parts. So a double can also be like 6.7 or -31.4. Okay, and that kind of makes sense. Int really means integer. It's a mathematical term. Double, the reason why it's called that is it's really stands for double precision floating point, because there's a single precision floating point, which is called float, that most programmers don't use that much anymore unless there's a good reason to, because they give you less precision. So what are ints good for? This is kind of like your go-to type. A lot of things are based on ints in C and other programming worlds. So this is kind of like your go-to type that a lot of things automatically get converted to, and you'll see ints used in a lot of times where you might not obviously think that makes sense. And they can be positive or negative, but they are limited. So ints can only go up to like 2 billion or -2 billion approximately. It's actually 2 to the 31 -1 or -2 to the 31. And so ints are good for any time we have like discrete values, anytime we're like counting, stuff like that. So things that can't be a fractional value in between. That's where ints are going to make the most sense. And where do doubles make more sense? Doubles are used a lot when we're dealing with anything with like related to engineering, measurements, science, things that don't have exact values. Think of as inexact. So they're fairly precise. We can get a lot of precision out of double, but not perfect precision. So just like in the way that if you wanted to write 1/3, if you wanted to write that as a decimal point, you could write 0.33333, but as many 0.3s as you wrote, you would never get exactly to the value of 1/3. Let's think of that as a similar thing with double, except they're actually in base 2, as weird as that is. And you'll learn about more details of that in IC210 next semester, your computer architecture class. So these are our basic numeric types, and in terms of input and output, they're actually going to be treated the same. So the functions that we use for input and output are readnum and writenum, and you can use those for ints or for doubles, and depending on what type you use, then it'll work correspondingly. Okay, then the next big type is character-based types. So we talked about numbers, but what about kind of language or character-based? This is not talking about characters like characters in a book or your inner character, but in computing, we use the word character to refer to like individual letters or symbols. So the name of that type for an individual character is CHAR. There's actually a big and meaningless debate over how to pronounce this word. Some people say car because it should be like a hard C based on the word character, where people say cares. And some people say char because it's CHAR that looks like the English word char. And that's what I say. So I'm going to say char. You can do what you like. So what is this? So this is individual letters. So like just the letter A or a capital X. But not just letters, can also be digits. So like a 2, or punctuation symbols like a question mark, and can also be weird stuff. So one strange character that you've seen is \n. And what this one is, it's a special kind of character that doesn't print out like a letter or a symbol would, but it actually means to create a new line. So that's called the new line character. And if you remember learning about ASCII in your Cyber 1 class, that's what chars are all about. And while we're on the topic, I'll just show you a nice thing. If you're ever on a Linux terminal, you know how wonderful the ASCII table is. Well, you can just type man ASCII and you can look up the whole ASCII table yourself. So we can see what's the ASCII value of like M. I can see that the ASCII value of a capital M is 77. All right, just a small thing. So notice that with chars, we use single quotes. And it would be an error if we tried to put more than one letter because a char can really just hold one letter. And then the other thing that you're more familiar with by now is what's called a string or a C string. The C string is not actually a built-in type. The C string is actually something else. It's built out of multiple chars, as you might guess. And we'll look at the details of what a C string really is underneath in a few weeks in this class. But for now, you can think of it as a string of characters. So a list or a string of chars. So C string we put with double quotes, and it could have length 1, so it could be like X. But when we use double quotes, that's a C string and not a char. But a C string can also have, of course, more than one character inside it, like there's my name. And it can also be empty. So if we just have a double quote and another double quote, that means an empty C string. And for these to read and write, we use different functions. So for C string, we use fputs to write, and we will use the read string function to read. And for char, we use the same name things, but for char. So instead of fput s, it's going to be fput c for a single char, and read char. And we'll see examples of those in a couple days. Okay, and then there's one more type. We talked about numeric types and character-based type. There's one more, and that is a Boolean type, which is actually called bool. It's the only type of its kind, and it can only have two values, true or false. And those words, true and false, are special keywords in your program that refer to the true and false values of a bool. So, you know, an int can be any number up to the billions, positive or negative. A char can be any kind of ASCII letter. A string can be a whole lot of things, any of our names, or a book, a whole book could be in a string. But a bool can only be two values, a true or a false. So this is going to be really important actually when we get into if statements in a little bit. And we can use these things to refer to true or false, but that's the same as writing 1 or 0. So true is the representation of the Boolean value 1, and false is a representation of the Boolean value 0. And one weird thing about Booleans is that there's no input output really for Booleans. We just use read num and write num. So if you want to print out a Boolean value, you would just call write num, and what's it going to print out is either going to be a 1 or a 0, nothing in between. So Booleans are really useful for when we want to make kind of decisions and do things like that. So there's more for us to say about what kinds of operations all of these things can take. But I am going to leave it here for now and just remind you that we have these different types of variables, 2 types of numbers, 2 character-based types, and 1 Boolean one. And that is that's what we want to talk about so far. And now the next thing that you'll think about in the readings is how you can use these, how you can combine variables of these different types, do computations with them, or all other kinds of wonderful things.